Hello everyone. Today let's look at what we call matrix. So matrix are also mathematical operators that deals with array of elements. So we have got 2 by 2 matrix, we have got 3 by 3 matrix, we have got 4 by 4 matrix. What do we use to define these things? For example, this one is a 3 by 3 matrix. It has got 3 rows and 3 columns. The columns and the rows. So if it has got 3 columns by 3 rows, we call it 3 by 3 matrix. The constituent terms in the matrix are called elements. So in this 3 by 3 elements has got 3 by 3 matrix has got 9 elements. That's 1, 2, 3, 4. All these one inside are called the elements. So today in 3 by 3 matrices we shall do the basic things, that is operation on matrices. Operation on matrices, that is addition and subtraction of matrices. We shall do matrix multiplication of matrices, and we shall also do determinant of matrices, and lastly we shall do inverse of 3 by 3 matrix. So these are the 4 things that we are going to perform in this video today. So for example, given a 3 by 3 matrix like 4, 2, -1, 3, -2, 4, 3, 2, -8 as your 3 by 3 matrix, that is A, and another matrix B given as -7, -5, 2, -1, 3, -8, 4, 3, -6 as matrix B. So we are told to perform the following matrix operation, that is add A and B, that is A plus B. Number 2, you are told to subtract B from A, that is A minus B. Also get the reverse, that is A from B, that is B minus A. Then compare these two, and you shall make a conclusion as our first operative. So let's do the first one, that is A plus B. A plus B shall be A plus B. You take the matrices, you get A, that is 4, 2, -1, 3, -2, 4, 3, 2, -8. That is A. Then you add to B, that is -7, -5, 2. Then -1, 3, -8, 4, 3, -6. So we want to do the addition. When doing matrix addition, you add the elements of each position in the building. You add this one to this to this, and -1 to 2. Each position you add to themselves in the building. That one shall give us 4 plus -7 gives us -3. Let's just write them in full, then we compress. That is 4 minus 7. Here we have got 2 minus 5. It is a negative, so we have a plus here. The negative signs come there. Then you also have -1 plus 2 in that point. Here we have got 3 plus -1. Here we have got -2 plus 3. And here we have got 4 plus -8. Then we have got 3 plus 4. Then 2 plus 3, and -8 plus -6. So this is our sum matrix. So if you sum the two, you get 4 plus -7 gives you -3. 2 plus -5 gives you -3. -1 plus 2 gives you 1. 3 plus -1 gives you 2. Then -2 plus 3 gives you 1. 4 plus -8 gives you -4. Then 3 plus 3 gives you 6. 2 plus 3 gives you 5. And -8 plus -6 gives you -14. So this is the sum of A plus B. A plus B actually gives you that. So what about A minus B? A minus B will actually be the converse of what we've just done. So that one shall be 4, 2, negative 1, 3, negative 2, 4, 3, 2, negative 8. Then you minus B, which is negative 7, negative 5, 2, negative 1, 3, negative 8, 4, 3, negative 6. So you do the subtraction. So you take 4, you minus 7, that is 4 minus 7, 2 minus 5, then negative 1 minus 2 as your first line, then 3 minus 1, then negative 2 minus 3, then you get 4 minus negative 8 in that order. The last column is 3 minus 4, 2 minus 3, and then negative 8 minus negative 6 in that format. So that one will be our difference matrix. So 4 minus negative 7 gives you 11, because a positive and a negative gives you positive. 2 minus 5 gives you 7. Negative 1 minus 2 gives you negative 3. Then the second row, that is 3 negative minus negative 1 gives you 4. Negative 2 minus 3 gives you negative 5. Then negative 4 minus negative 8 gives you positive 12. Negative 3 minus 4 gives you negative 1. And 2 minus 3 gives you negative 1. Negative 8 minus negative 6 gives you negative 2 in that order. So this one is A minus B. And we are told to compare with B minus A. So we reverse these states as B minus A. B minus A shall be in this format. That is, you now first start with B. That is negative 1, negative 5, 2, negative 1, 3, negative 8, 4, 3, negative 6. That is B. You less A, which is 4, 2, negative 1, 3, negative 2, 4, and 3, 2, negative 8. So you get the difference. That one shall be negative 7 minus 4, minus 5, minus 2, then 2 minus negative 1 as your first column in that format. Second column, that is negative 1 minus 3, then 3 minus negative 2, then negative 8 minus 4. The last row, that is 4 minus 3, then 3 minus 2, negative 6 minus negative 8. If you condense it, you get that this is 4 minus 4 gives you negative 11. Negative 5 minus 2 gives you negative 7. 2 minus negative 1 gives you positive 3. Then negative 1 minus 3 gives you negative 4. Negative 3 minus 2 gives you positive 5. Negative 8 minus 3 gives you negative 12. 4 minus 3 is 1. 3 minus 2 is 1. Then negative 6 minus 8 gives you positive 2. So this is now B minus A. If you compare this one and A minus B, which we have found the result here, you realize that A minus B is actually negative of B minus A. The two are in that comparator. So you can do one and get the reverse of the other. So far we've now done what we call matrix operation, that is addition and subtraction. So what happens in the case that we have now to perform a matrix multiplication? Matrix multiplication. Matrix multiplication. So before we do matrix multiplication, I want to give us a scientific example. For example, given a matrix like 4, 3, 2, 1, 4, 3, 2 in that order, then 4, 3, 4, 6, 7 as a matrix. Given this is matrix P, and matrix Q is given as -1, 3, 6, 4, 3, 4. And this is matrix Q. And you are told to do P plus Q or P minus Q. P plus Q or P minus Q. You are told to perform such a matrix. This is a 3 by 2 matrix, this is a 2 by 3 matrix. So what you do, you complement each matrix with zeros so that you'll be able to perform the addition. So this one, to do this, you just say 4, 3, 2, 4, 6, 7. Then since that you do not have the third row, you add 0, 0, 0. So it is a 3 by 3 matrix plus, you now complement this one also -1, 4, 3, 3, 6, 4. You complement the third column with zeros for you to be able to perform such operations. So you just do the direct computation. That is 4 plus -1 gives you 3, 3 plus 4 gives you 7, 2 plus 0 gives you 2, 4 plus 3 gives you 7, 6 plus 3 gives you 9, 7 plus 0 gives you 7, 0 plus 6 gives you 6, 0 plus 4 gives you 4, 0 plus 0 gives you 0. So if you complement the rows and the missing columns, you'll be able to perform the permutation directly by just complementing with the 0. So if you are given an incomplete 3 by 3 matrix, complement it with zeros to perform the operation. So let's do a matrix multiplication. Matrix multiplication. So let's have a simple matrix so that we can do multiplication of 2. So for example, given that matrix A is given as -2, 1, 3, -3, 2, 4, and then 2, 1, 1, that is matrix A. And matrix B is given as -3, 4, -5, 2, 1, 1, 0, 3, 2 as a matrix. So given that matrix A is equal to this and matrix B is equal to this, then you are told to get A dot B or A cross B. Matrices are scalars, so you must not confuse A dot B and A cross B, the one in vector. So matrices are scalars. So if you're given A times B, multiply A and B, what you do, you write them in adjacent order. That is, A multiplied B shall be equal to -2, 1, 3, -3, 2, 4, 2, 1, 1, that is matrix A. You multiply with matrix B, -3, 4, -5, 2, 1, 1, 0, 3, 4. So to perform this operation, you need to master what we call the rows and columns of a matrix. Rows and columns of a matrix. Rows and columns of a matrix. So what you do, you consider the first row and the column. So you multiply rows and columns. For example, A multiplied with B, you take the first row of A, that is -2. -2, you multiply by the first element of the first column, that is -3. Then you add them downwards. Then you take 1, you add 1 multiplied by the one in the row. You are moving across, this one you're going downwards. 1 multiplied by 2, that is 1 multiplied by 2. Then you add 3 multiplied by 0. 3 by 0. So then you go again. The first row by the second column. First row by the second column, then you write it in the middle. That one shall be -2 by 4, -2 multiplied by 4. Then 1 multiplied by 1 plus 1 multiplied by 1 plus 3 multiplied by 3. 3 by 3. So you put that imaginary line to divide the elements. That imaginary line, you put that to divide the element. Then you check the first column again, multiply by the first row multiplied by the last column. That will be negative 2 by negative 5 plus 1 multiplied by 1 by 1 plus 3 multiplied by 4, 3 by 4. So you are through with the first row with all the columns. Then you go to the second row, multiply by all the columns in the same synergy. That will be negative 3 by negative 3 into negative 3 plus 2 by 2, 2 by 2 plus 4 by 0 plus 4 by 0. Then you get the second row by the second column. That is negative 3 multiplied by 4 plus 2 multiplied by 1 plus 4 multiplied by 3. 4 by 3 in that format. Then you take the second row or the middle row by the third column. That one shall be negative 3 multiplied by negative 5 plus 2 multiplied by 1 plus 4 multiplied by 4. So you've done with the second row also. So you go to the third row, multiply by all the three columns independently in that format. So that one shall be 2 by negative 3 plus 1 by 2 plus 1 by 0 in that format. Then the third row was the second column, that will be 2 by 4 plus 1 by 1 plus 1 by 3. 1 by 3 in that format. Then you go to the last column, last row by the last column. That one will be 2 by negative 5 plus 1 by 1 plus 1 by 4. 1 by 4. So this one shall be the product of the two matrices. So you solve the independent part and add a 6 there. So negative 2 by negative 3 gives you 6 plus 2. This one is 0. Here, this is 9 plus 4. 4 by 0 is 0. Then this is negative 6. This is plus 2. That's the first elemental limit. Then negative 2 by 4 gives you negative 8. 1 by 1 gives you plus 1. Then 3 by 3 gives you plus 9. Negative 3 by 4 gives you negative 12. 2 by 1 gives you 2. Then 4 by 3 gives you positive 12. 2 by 4 gives you 8 plus. Then 1 by 1 gives you 1. 1 by 3 gives you 3. The last end is negative 2 by negative 5 gives you 10. 1 by 1 is 1. 3 by 4 is 12. 3 by negative 5 is 15. 2 by 1 is 1. Then 4 by 4 is 16. 2 by negative 2 by negative 5, sorry, this is negative 10. 1 by 1 is 1. Then 1 by 4 is 4. So this is the sum of the product of the two matrices. So sum each point. 6 plus 2 gives you 8. 9 plus 4, that is 13. Negative 6 plus 2 gives you negative 4. Negative 8 plus 1 plus 9 gives you 2. Then negative 12 plus 2 plus 12 gives you 2. 8 plus 1 plus 2 gives you 12. 10 plus 1 plus 12 gives you 23. 15 plus 2 plus 16 gives you 33. Then negative 10 plus 1 plus 4 gives you negative 5. So this is actually the product of the two matrices A and B. So the key point in that when you are doing matrix multiplication, you multiply rows by columns. The way we've done it independently, then you sum them, then you get a 3 by 3 matrix in that format. 3 by 3 in that format. So the next point we want to know is how to get the determinant of a 3 by 3 matrix. Determinant of a 3 by 3 matrix. So let's use the same matrix A. When getting a determinant of a matrix, we know how to get a determinant of 2 by 2 matrix. For example, if you have a 2 by 2 matrix as A, B, C, D, and you are told to get the determinant, what you do? You get A multiplied by D minus CB. This one will give you the determinant. So what happens in the case of a 3 by 3 matrix? So for 3 by 3 matrix, you intend to form a 2 by 2 matrix from a 3 by 3 matrix, then you use it to solve the situation. So for example, before you do all that, there is what we call the sign array in display. So if you have a 3 by 3 matrix like matrix A, you get what you call a sign array, that is plus minus plus minus plus minus plus minus plus. So this sign array is used to assign the various elements in the various positions. So you take the positive element you assign to this one, negative you assign to this, and positive you assign to this. So let's get the determinant of matrix A. Determinant of matrix A. To do that, you start at a point element -2. You close the column and the row where 2 is. You close that column, the row and the column. You end up remaining with a 2 by 2 matrix. So that is what you write. That is 2, 4, 1, 1. That's a 2 by 2 matrix. Then you take this element here, multiply by its sign, that is -2, multiply by positive sign, it will still remain -2. Then you go to the second. You can use any row or any column. So we opt to use the first row. So we have used -2. Now we come at this point of 1. We close the row where 1 is and the column where 1 is. If you do that, you end up with remaining with a 2 by 2 matrix. That is -3 and 4 in this side, 2 and 1. But you take the sign of the element, this one, the one that we had selected, multiply by the sign in this array, that is -1, then you multiply it there. Then again, you come to the third element in that row, that is, you come at point 3, you close the column where 3 is, and the row and column where 3 is. You end up remaining with a 2 by 2 matrix, that is -3, 2, 2, 1. Then you close. Then you take the element is 3, multiply by the sign that is positive, then you put it there, +3. Then this one shall give you the determinant of that matrix. So let's perform it. This one shall be, now after getting this 2 by 2 matrix, you use the same method of getting the determinant of a 2 by 2 matrix. That one shall be -2 into 2 by 1, that is 2. Then you minus the reverse diagonal, that is 1 by 4 gives you 4. Minus 1 into -3 by 1 gives you -3. 2 by 4 is 8, then minus 8 in that format. Then plus 3 into -3 times 1 is -3. 2 by 2 is 4, reverse diagonal is minus in that order. So this one gives you -2 into -2 minus 1 into -11 plus 3 into -7. This one gives us, this is a positive sign, this is equal to +4, this is plus 11, and that one is minus 21. So if you sum the two, you'll get -6. You'll get -6 as the determinant of that 3 by 3 matrix. So you can even use that one. We perform that the determinant of that matrix using the first column. You can even use using the first row. I mean, you can even use any column to get the same thing. So let's use any one column. Our matrix was -2, 1, 3, -3, 2, 4, 2, 1, 1. So let's use this column, the third column, to get the determinant. So we must not forget the sign, that is plus minus plus minus plus minus plus minus plus. So you first pick the sign. We are using the third column. We first pick the sign, that is positive, multiplied by 3, you get positive 3 into. You stand at this element, you close the row and column where it is. So you will be closing that point and this point. You end up with that 2 by 2 matrix, that is -3, 2, 2, 1. Then you go to the second element, that is 4. The sign is negative, so you multiply by 4, that's -4 into, close the column where 4 is and the row. So you'll be closing the middle one and the first column. So you'll end up with this -2, 1 and 2, 1. Then you go to the last element, that is at 4. By the sign, it will be +1 into. If you close the column and the row where 1 is, you end up with that 2 by 2 matrix. That is -2, 1, -3, 2. So perform the permutation, you shall get -3 by 1 gives you -3, minus 4, that's 2 by 2, multiplied by 3 in outside. Then -4 into, -1 by 1 is -2, 2 by 2 is 2 minus, which means that order, -2 by 1, this is +1, -2 by 2 is -4, 3 by -1 is -3, minus gives you a positive in that format. So if you do this, this one gives you, this is -12, this is minus, -3 minus 4 gives you -7. So -7 by 3 gives you -21. This is 2 minus 2 gives you -4. By -4 gives you +16. -4 plus 3 gives you -1. By 1 gives you -1. So if you do the 2, you'll get, this is -22 plus 16 gives you -6. So you see, irrespective of the column or row you use, you'll get we use the first column, we found the determinant to be -6. We've used the last column, we found the determinant to be -6. So irrespective of the column or row you use, you'll get the same determinant. And the determinant is what we call the magnitude of a matrix. Magnitude of a matrix. So if you are told to get, for example, this one is written that way, the magnitude of a matrix. So this is actually its determinant. So in our next video, we shall be doing inverse of 3 by 3 matrix and application of matrices in solving simultaneous equations of 3 unknowns. So stay posted and we shall be in the next video. Thank you.